Hello, I'd like to start with the notion of dimension today. So to do that, let me introduce the following setting. So I'm going to set W to be all of R2. That way, we don't have to check that W indeed is a subspace. So W is a subspace of R2, of course. And I'm going to set S to be the collection of vectors 1, 0, and 0, 1. This way, we see that S is a subset of W, right? So now what we have here is that S, so note that S generates W, first thing, and S is linearly independent. In other words, we have that S is a basis for W. So my question is this, is there a way to enlarge S? But not only enlarge it in any way, enlarge it and still maintain the properties that it has already. So generating W and being linearly independent. Now, to generate W, it's not so difficult. All that we have to do is to take elements that are from W itself. But it's this second part that is kind of fishy. Let's take a look at this. So, can we keep S linearly independent? Let's see. To do that, let W be a vector in W and construct the following set S tilde, which consists of S adjoint with this new vector W. So S tilde is simply the set 1, 0, 0, 1, W. But as we know, W is all of R2. So this little W vector can be written as W1 and W2. Now, to verify the linear dependence or independence of this set, I'm going to introduce this. So let alpha 1, alpha 2, and alpha 3 be real numbers. And assume that once I form a linear combination with these elements and the elements from here, I obtain the zero vector. But look, I no longer have this this force that is telling me that all these coefficients must be zero. Because now, even though I have this assumption, I can say, oh, set alpha 3 to be equal to 1, alpha 1 to be negative W1, and alpha 2 to be negative W2. So not all of them are equal to 0. So that says that S is not linearly independent.